In this lab, like in previous, looking at the weight attribute in BGP and how I can use this to accomplish certain goal. This is the first attribute that is going to be tested for the best path in BGP. So in the previous lab, I applied the weight, higher weight for prefixes learned from R3 rather than Internet 1. As a result of that, the path changed from the closest path towards the prefixes originated by AS100. It goes through AS30 and AS100. Now, so let's go ahead and see the configuration of that real quick. So I'm receiving show IP BGP regular expression space 1 originated by 100. So currently I'm using next hop R3 to reach those prefixes. Now obviously this was accomplished by using BGP configuration and applying the weight 100 for everything I learned from neighbor, which is R3, higher weight. As a result of that, higher weight wins. When there are two possibilities, this one is going to lose because this one is higher in ranking here. I'm going to remove that. Now I'll do something else with this. Now the limitation of weight parameter is that it can only be applied on a single router. It's a local to the router, so it only makes sense to use it when I have multiple connections to multiple ASs on a single box. However, better option is local preference. That's going to be the next one. But before I go for local preference, I want to do one more thing with weight. I want to make sure, let's just remove it, 10, 1, 13, 3, weight 100. So let's remove that first. All right, it's removed. What I want to do now is I want to make sure that, let's say, half of the prefixes are reachable via R3 and half of the prefixes will be reachable via AS100. So I can do some sort of load balancing when sending traffic towards the internet and maybe use both gateways as my policy here. So how would I do that? So obviously now I have to do show IP BGP. I'm still using weight 100. So after removal, I need to request R3 to send those prefixes again. So it's now applied the default weight 10. Clear IP BGP 10 1 13 3 in. So now show IP BGP. Now it's 0. So I prefer now for all those prefixes my Internet 1 router back again. And the reason why that is because obviously everything is equal until we get to the AS path length. And shortest path is always the default, the winner. 2 paths versus 1. This one becomes the best path. Okay, so how do I do that? How do I do load balancing here? So in this example, what I'm going to try to accomplish is that if R1 is facing the internet and it has 2 service providers available, let's just maybe for certain prefixes, I'll choose 4 of them as an example. Let's spread the load of the traffic going out of the system AS500 towards the internet using both gateways. So after removal of the previous configuration, what I have in fact here, let's see that, do show IP BGP regular expression learned from the space originated by 100 and $sign. So in this particular situation, what I have is that for all those 4 prefixes, the gateway is always in Internet 1, right here. Let's spread the load of the traffic using both gateways. How would I do that? What I'm going to do is I'm going to try to do this efficiently. So the first 2 prefixes 100.10.0 and 100.10.1 should go to Internet 1, just like now. But the other 2 should always go through R3, which is the 10.1.13.3 gateway. It's not happening at the moment. It's all prefixes are now. So if I do show IP route the BGP, everything 110 is going through the same gateway right there. Okay, so let's go ahead and do that. So to do that, I'm going to create a prefix list and apply a route map for both gateways. Now, just to save a little bit time of video here, so here's my first prefix, 100.10.0.0/24, 100.10.1.0/24. So the mask that is 24 currently used is here. Now, the way I do it is I do this in my mind, kind of, I see that there's 0 and 1, two possibilities occupy 1 bit, but just to see that visually, what would be the mask, summary mask for those two prefixes? It's the mask that bits don't never change, so the first 8 bits don't change, the next 8 bits don't change, so 16 bits don't change here, right? But here, everything is the same until the last bit in this. So 23 bits now is my network mask. That's /23. 23 bits don't change. So if I use the lowest value with a shorter network mask, what I'm accomplishing is I'm summarizing those two prefixes to just one. And we'll see that shortly in my prefix list. So what I'm going to do is prefix list. Let's call it subnets 1. I'm going to say permit and 100.10.0.0. I'll be checking the first 23 bits as per summary routes, but the prefixes themselves are 24 bits, so less or equal 24 bits. So I'm checking the first 23 bits. If they are the same, it's just one summary route, like previously shown. And subnet 2, so that's going to be for, let's say, Internet 1 router, and this one is going to be the 2. It's the same thing, 2 0, and 2 and 3 will be covered by that. Propose that you do that kind of summary yourself and see that the number of bits don't change when you convert them into binary. I now will create a route map for int 1 permitting, and this is one thing that we can get caught very quickly. What I'm going to do is match now on IP address prefix list and subnet 1. I will set for these set weight 100, and now this is the gotcha. I need to permit everything else, so I need to, if I didn't permit something other than those two prefixes, 110.0, 110.1, I would not allow 110.2 to be accepted. So I need to permit them, so I use the same name of a route map and permit, let's say 20, permit everything else, but don't do anything with it, don't apply any weights, just apply the default weight, which is 0. And I'm going to create a second route map in similar way for R3, permitting 10 match IP address prefix list subnet 2. For these applied weight 100. So I'm going to apply this for incoming updates from router 3 set weight, but also allow everything else as well, and don't apply anything, just accept them as they are. So with these two route maps, I can go to BGP 500 and say for my neighbor 10.1.10.254, is it? Actually, let's do show IP BGP summary. Yes, so neighbor 10.1.10.254 route map for int 1 inbound, for neighbor 10.1.13.3 route map for R3 inbound. So with these, I apply those route maps. Obviously now nothing happens until I ask for those. Show IP BGP summary. Actually, there's no weight applied. But if I do clear IP BGP for all neighbors, let's ask all neighbors for incoming updates. So now at this point, I applied 4. Let's go for regular expression so we can see better. Regular expression originated by 100s. So what we see here is that for 110.0 and 1, the gateway is Internet 1, but for 110.2 and 3, the gateway is 13. So show IP route BGP, and this way I am using load balancing in my network. So if I go back here to R2 and the trace route to 110.0.1, it goes through router 1 and internet 1. The same for this. And if I go for 2, it's going through router 1, router 3, and it gets to the internet, and the same for 3. So this way, using just wait attributes, I did the load balancing of my traffic. So I use both gateways for the outgoing traffic from my system.